Alrighty, welcome everyone to day 25 of Avid Code. Merry Christmas. And unfortunately today, usually the second part today is a freebie, but you have to have 49 stars in order to get that. I will be too short, so unfortunately I only get 1 star today, but the least we can do is still solve the problem. So, as the expedition finally reaches the extraction point, several large hot air balloons drift down to meet you. Crews quickly start unloading the equipment for the balloons brought, many hot air balloon kits, some fuel tanks, and some fuel heating machine. The fuel heating machine is a new addition to the process. When this mountain has a volcano, the ambient temperature was more reasonable. Now it is cold and the fuel won't work at all without being warmed up first. The elves, seemingly in an attempt to make the new machine feel welcome, have already attached a pair of googly eyes and start calling it Bob. To heat the fuel, Bob needs to know the total amount of fuel that will be processed ahead of time so it can be correctly calibrate heat output and flow rate. The amount is simply the sum of the fuel requirements of all of the hot air balloons, and those fuel requirements are even listed clearly on the side of each hot air balloon's burner. You assume the elves will have no trouble adding up the sum numbers. You're about to go back to figuring out which balloon is yours when you get a tap on the shoulder. Apparently the fuel requirements use numbers written in a format the elves don't recognize. Predictably, they like your help deciphering them. But you don't recognize the number form either. For example, okay, fortunately Bob has labeled with support phone number. Not to be deterred, you call and ask for help. That's right, just supply the fuel amount to the more than one burner, no problem. We just need to add together our special numeral analog form fuel units, patent pending. Way better than normal numbers. For you mentioned that it's quite cold up here and you ask if you can skip ahead. Okay, our special fuel units, snafu, nice, are sort of like normal numbers, you know, starting at the right. On the right, normal numbers have ones place, tens place, hundreds, so on. Or same, except it uses powers of 5 instead of 10. Starting from the right, you have a ones place, a fives place, so it's base 5k. The engineers, but I did that instead of using digits 4 through 0, they use 2 1 0 minus written and double minus. Minus is worth -1 and double minus is worth -2. So because 10 in normal numbers is 2 5s and 1 1, the snafu is written as 20. Since 8's, so because 10 in normal numbers is 2 5s and no 1s, and snafu is written as 2 since 20. Since 8's, oh, it's base 5, but there's negative numbers. Okay. You can do in direction 2, say the snafu numbers. That's 2 in the 6th place, yeah. Okay, alright. Yeah, so I say you're connected via our premium uplink service, so I'll transmit a handy snafu brochure to you now. Do you need anything else? Yes, get the fuel even work in the temperatures. Wait, it's how cold? There is no way the fuel or any fuel would work in these conditions. There are only a few places in the world where you say you are again. Just then, notice that one of the elves pour a few drops from the snowflake-shaped container into one of the fuel tanks and think, okay. Yeah, based on this process, snafu numbers, I think they'll love me converted decimal numbers like that. Okay, so here's all our snafu numbers. Alright, so this is just converting from base 5 to base 10 awkwardly because it uses negative numbers instead of just whatever. I didn't know I did that. So as you go to the input, you discover some buttons you expect are missing. Instead, you're met with the buttons labeled Bob needs the input value is okay. Reversing the process, you can determine that for the decimal or forward any other number needs support. Okay. So we need to sum up all the numbers and then convert it back to snafu. Oh, the back to snafu bit might be rough. I can do the conversion from snafu to ours, but how do you go from snafu to whatever? I mean, does it change anything? I'm trying to like, okay, let's just go. I mean, I could fear, but let's just go from the one to the other. So long sum equals 0. So public long get s I don't know, I'm playing about that snafu to des string snaf. So what this is going to be is just going to be for int I equals equals snaf dot length minus 1 while I is greater than or equal to 0. I minus minus, we're going to go reverse because it's easier to go that way. So we're going to have long decimal equals 0, return decimal, and so it's going to be decimal plus equals snafu int num equal int num. So let's just do a switch statement on snaf char at I. Actually, we can do this. We can do int num equals that. But we can't. Well, it just raises the power. Case 2 return 0. So it's 2 1 0 minus and equal for double minus. -2 -1 0 1. Fine, do that. So this is gonna be then math dot power hold on, I'm forgetting my bases here. Of number to the I, right? Right? That's, yeah, ones to 0. It's to the 1. Sorry. I plus 1 used to be. Oops, that's outside. So it's just that, right? Sure, let's try it. String s and inputs. Sum plus equals snafu to decimal s lap sum. Let's see if it is right. Oh wait, that's gonna be hold on, I gotta use the example input because I don't know how to convert back. No. Okay, if I just give you, okay, it'd be helpful if I gave it the right thing first. If I give you that, you give me 67. If I give you that, what do you give me? 8. Gotcha. It's reversed. Right? Yeah. Minus I. Because if it starts... Yes. Oops. Forgot I parenthesis. Try it again. So I should be getting 906 from this. I get 20. Eventually I'll get this right. What the heck are you doing there? Num is 1 and I is 4. So I is 4, so it's going to be 5 minus 4 is 1, so that's 1. Yeah. Decimal is 1, so it should be 5, so it should be 6. What? Why is math up power now? It's not, I did the wrong way. It's num times, no. Num, it's 5 to the power num times that, right? What am I, why can't I do conversions? Why can't I convert from different bases? I'm blanking so hard. One 5. Because I am doing it right. It's this. Try that again. One too many. 9 of 6. There we go. I was like, I thought this was. Okay, we're good. And just to make sure, is this gonna let me do this? So if this is done right, I should call it trim, but it's fine. So she gets 480, 90, good. Okay, so I can convert one way. Going backwards though. Because you can't. If there's a negative, there's got to be a way to shift it down. I mean, in theory, the negative makes no sense. The negative is what's killing me. There's gotta be a way to reverse, because if you have a negative, there's what's stopping you from just using because you have 3, 4, 5. So the pattern is, it works like normal, but if you have a 3, I might be able to do this. Okay, hold on. Hold on. If I just convert let's just do decimal. So do the same thing. And actually we can just change this to be in decimal. Because what I can do is while decimal does not equal 0, string snafu equals this. That's probably making me want to be a stream builder, but that's fine. The largest power. Finding the largest power is. Yeah, I could do it the long way. Or the hard. There's a fast way to do this, isn't there? Fine. And start power. I can't think of the quicker way to do this. While decimal is less than math dot power of 5 to, sorry, while it's greater than okay, there we go. So I is gonna be the start power, greater than or equal to 0, I minus minus. Okay, that's string snafu. Okay, it doesn't matter. So what we're gonna do is we're just going to hard code it as if it was 0 to 4. As if you could use 0 to 4. We're gonna do that. So what's gonna happen is we're gonna do snafu plus equals decimal divided by we need int equals math dot power. There's a fast way to do this, and I cannot think of it for whatever reason right now. But 5 to our start power. I want a long, probably. No, what do you want? A double. Cast to an int, please. Division. Convert that to that. Okay. And then decimal power. It's not the power, but whatever. Actually, no, we should be doing this. So this should be I. Okay, so this will give us correctly on snafu, but now the problem is your snafu is in, actually let's just do this. Let's do let's turn it long or a string. Let me take these numbers in now. Let's see if this can correctly do it. This is way longer than it should do. There's a totally fast way to do this, and I just cannot think of what the faster way to do power conversion is. I don't know why I cannot think of it. Okay, so run through this. Instead, we can do is just a system out print line of decimal to snafu integer % of s. So I think that's converted it correct, right? Yeah, 3 to 3. This looks right to me. 37,122. Yeah, okay. So dig it. So 37,122. So it is working. Now the problem is that we have numbers like 3 and 4 that it can't handle. Well, we have a handy conversion system for 3 to 4. If it is 3, this becomes a double minus, and we simply add 1 to the following one. So we can go through and basically do reverse, or it's basically subtraction. If you were to take 8 minus 9, how you pull from a 1 over and do that. Or it's actually more like addition, where you're doing this one, adding 1 to the next, and you're kind of going up that way. So what we can do is we can do for, what can I do with snafu? Can I do like char? Let's do, okay. Int I equals snafu dot length minus 1, while I is greater than or equal to 0, I minus minus. And what we can do is if snafu dot char at, we should save this to a char c, char at I, if c equals 3, we need to do snafu dot so just a set char at I to be an equal sign. So we need int carry. Actually, we just do boolean carry. Technically we could get a 5, and if we get a 5, well, that's just a 0 1 up. So okay, so carry is false. This will set carry equals true. So we gotta do first, we gotta check. First we do, actually let's finish this out. Else minus 3, 4, 5. This just hits 0. So now we're saying carry. What we gotta do first is that when we get this char, we need to do if carry c plus plus. This will just set to the next number. Yeah, because it's all correctly done there. And then we do carry equals false. And that should, if carry at the very end, that means we need to do is snafu dot append. Actually, we can just do this. String to return equals equals snafu this. If carry to return equals 1 plus to return, and to return. And in theory now we should be able to do this, pass in sum. And if I did this right, like make that a long, I will get a snafu number that doesn't look quite right. Because I put all those in. That doesn't, something went wrong. Oh. No, let's just YOLO and put my puzzle input in. I think I did this right. I'm gonna YOLO it. Ah, well, I clearly didn't do it right because I get 6, 7, and 9. Nice. Huh. Okay. Clearly, not correct. All right, let's try this one more time. I wish we had a better example input that wasn't this, but it's fine. It's actually 2, -1, 0. It's 1, okay. So something didn't go right here. Debug time. Oh, it's like why it stopped there. Okay, so carry is false. The first character that's not right. Wait, no, that is right. The heck? Oh, this is the snafu, right? This is the snafuified one. So we get, okay, 0, 3. So this looks right. This actually looks right. Okay. So no carry. Carry is false. So we have 3. What's our first? Oh, 0. Right, 0. Okay. So nothing happens to it. It stays the same. Okay. Carry is still false. C is now 3. Reset the char here to an equal sign. That's right. And there is a carry. Cool. So now we have 0 that. We have a carry now. Carry makes it 1. Cool. Nothing happens to it. Next character is... Oh. Oh, I totally forgot to do snafu. Ooh. Just in case, snafu set char at that to be C. Hey, okay, so now if I go back to my input, why does this break down so hard? Is it because of the int? Is I'm using int? Oh. That might be why. Hey, that looks more right. Give that space at the beginning. Yay! And part 2, I'm gonna guess, is the harbor balloons quickly carry to the North Pole. As soon as you land, most of the expedition is escorted directly to a small building attached to the arcade. 50 stars to fill the blender. Wait, the head smoothie chef has just finished warming up the industrial grade smoothie blender to drive. Fill the blender as soon as you get at. Only 49 stars to go. I need 2 stars. Unfortunately, I'm too short. 16 and 20 something. 16 and 22. I'm close, but that's not bad for this year. Not bad at all. I'm sure the leaderboard for today was pretty quick. Wow, very quick. Yeah, I should have had that a little bit quicker, but for some reason I had just... I know there's got to be a better way to do this than the whole carry bits I did. There's got to be something better. I just can't think of it at the moment. I don't know, but either way, quickly though, let's go over how to solve today's is just a binary, not binary. Well, it is binary, but it's binary. Or not, it's conversion of base 5 to decimal or base 10. Traditionally though is for either base you have 0 to 1 less than the base you're in. So base 5 is 0 to 4. Base 10 is 0 to 9. That's our typical number, 0 to 9. But snafu, what they call there, is a little bit different in that it's base 5, but you have the number 0, 1, 2, and then minus sign and equal sign. Minus sign meaning -1, equal sign meaning -2. they still get put into the conversion and either the same way. We have to do is first do a conversion between our characters and this. I could have probably made this like a little list here, like a little mapping, whatever. So we convert from the character code to the actual number it means, so -1, -2, and then you just do the power, because this is base, so base 5, to the power of where we're at. So if we go from right to left, we start at 0. We convert this again from the length of the string, -1 minus I, that could says 0 there. But no, 0 to the 5th power is 1. Multiply that by how many numbers are in that position. So 3, or if we have 3, whatever, it's 3. 5 to the first power is gonna be 5 times, let's say we have 2 there, that's gonna be 10, so on and so forth, and whatnot. So that will convert a snafu to decimal, so like 2 to -1, so on and so forth. That's not too bad. It's normal conversion of base 5 to base 10, just with the negative numbers instead of 0 to 4. Going backwards though, we do the exact same thing. First we need to do is we need to figure out what the largest power we can get is. There's definitely, I don't know why I can't think of the fast way to do this. There's gotta be a faster way, I just cannot process it. But the brute force way, or like the slow way, I guess, is to just basically find the first power of 5 that is larger than our number, subtract 1, because if it's larger than it, then you can't, it doesn't work. But find the first power larger than the number, subtract 1 off, and then now we have where our starting power is. So go from that, slowly divide that out of our number. So slowly, place by place, figure out how many 3s, how many 2s play, how many 3's power, 2's power, 1's power of 5. You can go get fit in the number, slowly knock the number down. Keep track though of how many fit there. Again, we're not worrying about the negative numbers here, but we are going from 0 to 4 as you would normal base 5. And if you were going to base 5, this would be the end of it. You would return what we got here. Because this is not normal base 5, we have negative numbers, and we have to go through and do this logic. This logic here is going through the normal base 5 and is saying, oops, if I bring up the example here, it is saying if we get a 3, which is if we get a 3 in the position, that doesn't work. That instead gets converted into a 1 with a -2. 4 is converted into a 1 with a -1. 5 is converted into a 1 minus 0, 1 with a 0. 6 and 7, those are normal base 5 numbers. This is easy. We can simply convert, the 3 to this and 4 to that and 5 to that. That's easy. The issue is we then get a 1 added on to the following position. That gets solved by this carry bit here. So we have this boolean as being a carry. The first thing we do is when we check after a number, check if we have a carry. If we have a carry, this number is now 1 larger. So say right here, 8, this was a 1 and 3 here. Unfortunately, that 3 doesn't work because you can't have a 3 in their snafu. So we instead convert that 3 into the double equals, just a regular equal sign, and then add 1. But there's already a 1 here, so we have to add 1 onto 1 to get 2. That's how you get 2 there. And the way we do, again, why we do that is with that carry bit that we have here. This just takes a 1 in, adds to the carry bit to give it a 2, and then we process again. 3 gets converted to the equal sign, set the carry bit to true. 4 sets a negative sign, carry bit to true. 5 gets set to a 0, again, carry bit to true. I could have moved this carry down to here, but whatever. This just sets it in case we did change it with the carry. And that is it. We didn't output it. Again, checking the last carry to make a 1 there. And that is it. That is day 25 complete. That is Advent to Code 2022 complete. I still have 3 more stars to get, but I'll be doing that in the future. Probably it's going to take some time, and we're circling back in the future. But at any rate, that'll about do it for me. Thank you guys for watching. Thank you guys for sticking with me for this entire Advent to Code year. Greatly appreciate you made this video. Now, feel free to give me a like, give me a comment down below, and tell me if you got 50 stars. But anyways, thank you for watching. See you guys next time. Peace out.